At the end of this module, you will be able to describe the purpose of IPS, describe IPS policy components, explain how to configure IPS policies, describe the purpose of a user firewall, explain how to configure an integrated user firewall. Initially, network defense consisted of basic stateless firewall protection. Network devices, such as routers, often provided this feature. As network attacks became more sophisticated, network defense had to adapt. Stateful firewalls, authentication mechanisms, and VPN devices that encrypted traffic offered additional protection from harmful network traffic and malicious users. Traditional stateful firewalls might not detect some forms of malicious traffic because manufacturers design VPN devices and firewalls for high-speed operation. For more advanced attack detection, the solution is to use Intrusion Prevention System, or IPS. The Juno's IPS feature provides additional security beyond a firewall. While a firewall traditionally inspects only layers 3 and 4, the Juno's IPS feature will decode and reassemble the data stream, enabling the inspection of application layer traffic or layer 7. When IPS reassembles the data stream, the Juno's OS examines the stream for specified attack patterns. If no attacks are found, the software forwards the original packets. If the software detects an attack, IPS can drop packets, close or drop sessions, prevent future sessions, and log attacks for review by network administrators. In the past, you often had to take a reactive approach to network security by parsing logs for security threats before being able to take action. In the meantime, the network remained vulnerable. Using IPS, you can be proactive by stopping attacks as they occur and by preventing future attacks. IPS can be an important part of network security, but it is generally resource-intensive, so it is best practice to combine IPS with other security mechanisms to protect your network while minimizing resources. The Juno security device offers some of the following security options, in order of least used resources to most used resources: stateless firewall filters, screen options, security policies, Unified Threat Management or UTM, and IPS. Click each security mechanism label to learn more. To reduce overall resource usage on the Juno security device, it is best practice to filter as much traffic as possible before passing the traffic to IPS for deep packet inspection. For example, if traffic is denied by a security policy, then it will never be inspected by the IPS engine, even if this traffic has an embedded attack. No resources are wasted on inspecting at layer 7 because this traffic was blocked early on. The Juno security platforms have IPS functionality fully integrated into the Juno's OS. This integration requires no additional hardware or operating system, resulting in lower costs, lower management overhead, and increased operational simplicity. Juniper Networks maintains a database of attack signatures for use with the IPS feature. With a valid license, users can retrieve updates manually or automatically at scheduled intervals. The full security package download includes several policy templates. These policy templates offer protection against a variety of common attacks. Once you install the policy templates, you can customize them to fit the traffic patterns of a particular network. In the past, you often had to take a reactive approach to network security by parsing logs for security threats before being able to take action. In the meantime, the network remained vulnerable. Using IPS, you can be proactive by stopping attacks as they occur and by preventing future attacks. IPS uses an attack signature database to protect your network from thousands of known attacks. It can also detect protocol anomalies to protect your network from unknown or potential attacks. The attack database updates as new threats emerge, keeping the Junos OS on the leading edge of network defense. Juniper Networks maintains a web-based security portal listing the latest attack database updates, Microsoft security bulletins, attack trends, and other useful security information. An IPS policy enables selective enforcement of various IPS attack detection and prevention techniques on network traffic passing through the IPS engine. Administrators can write very granular rules to match a section of traffic based on zones, networks, and applications. These rules can then apply specific attack prevention techniques on that traffic and take active or passive preventive actions. The structural view of an IPS policy is displayed. An IPS policy can consist of two types of rule bases, an IPS rule base and an exempt rule base. A rule base is a collection of rules. Rules contain a collection of configuration objects and are similar in structure to a security policy because they use configuration objects to create match conditions and resulting actions. Once you create an IPS policy, an advanced permit of a security policy applies it. Many IPS policies might exist within the configuration, and in the past, you could apply only one IPS policy to an SRX device at a time. However, with the recent version of the Junos OS, you can specify the IPS policy in a security policy, which means that you can have multiple active IPS policies at the same time. The Junos OS uses configuration objects to build IPS rules. Configuration objects to match on include zones, source and destination networks, applications, and attacks or attack groups. The initial setup of IPS has two main parts: deploying and applying. Click each label to learn more. To begin managing the IPS signature database with Jweb, you must first download the database from Juniper. You can begin downloading the IPS signature database in Jweb by navigating to the Configure, Security Services, IPS, Signature Update Workspace, and clicking Download. Once the download begins, you can click Check Status to find the current status of the signature database being downloaded. Note that you must have a valid name server configured on the SRX for the signature database download to work. Next, you must install the IPS signature database. After you download the IPS signature database, you must click Install to install it. As with the previous download action, you can check the status of the install by clicking Check Status. It is always a good idea to keep the IPS signature database up to date. To this end, you should set up automatic recurring downloads and installation of the latest IPS signature database. You can accomplish this task by clicking Download Settings and configuring the automatic and recurring download and installation of the latest IPS signature database. Also, you can specify the URL to download the IPS signature database under Download Settings. By default, the SRX downloads the IPS signature database directly from Juniper. Policy templates are available for download and installation just like the attack signature database. They provide a quick and easy way for an administrator to set up a new IPS installation. You can apply the templates to your configuration to get a generic set of IPS policies. Every environment is different, so it is important to customize the IPS policy to ensure it is effective and efficient. These templates are then loaded on the SRX as IPS policies. You can customize each IPS policy regardless of the source. Alternatively, you can simply create your own custom IPS policy, which references different attack objects. After configuring an IPS policy, you must reference it in a security policy rule. An example of a security policy rule that has an IPS policy configured under the advanced security field of the rule is displayed. The action field of the security policy rule must be set to permit, or you cannot apply an IPS policy to the rule. Note that the displayed example does not show the name of the IPS rule that is applied to the security policy rule. It only shows that an IPS policy is applied to the rule. To examine which IPS policy is applied to the security policy rule, you need to edit the advanced security field of the rule. Networks have historically used the IP address as a way of identifying users and servers. This strategy is based on the assumption that users or groups of users connect to the network from fixed locations and use one device at a time. Network security enforcement, monitoring, and reporting based solely on IP information is not always enough for today's dynamic and mobile workforce. A user firewall allows administrators to permit or restrict network access of employees, contractors, partners, and other users based on the roles they are assigned or the user themselves. A user firewall enables greater threat mitigation, provides more informative forensic resources, improves record archiving for regulatory compliance, and enhances routine access provisioning. Two actions are triggered by the user firewall. It retrieves the user role and information that is mapped to a source IP address and determines the action to be taken based on match criteria within the security policy, which now includes a user identity field. In this example, each user's identity is determined, and then access to resources in the data center is assigned based on the roles. This allows users to work on multiple devices and from multiple locations and get the same access regardless of their IP address. It also makes provisioning access easier for everyone since access is no longer based on IP addresses that may be dynamically assigned. A single security policy can ensure that an entire team has access to the proper resources. To retrieve user and role information, the SRX polls Microsoft Windows Active Directory. This information creates the authentication tables that are searched for an entry with an IP address corresponding to the traffic. If an entry is found, the user is classified as an authenticated user. If not found, the user is classified as an unauthenticated user. The user name and roles associated with an authenticated user are retrieved for policy matching. Both the authentication classification and the retrieved user and role information are used to match the source identity field in a security policy. If the source identity is specified in any policy, the Juniper Security Devices User Firewall module enforces user-based and group-based policy control over traffic. If the source identity field is not specified in any policy, then user and role lookup is not required. User identity information can also be incorporated as criteria into advanced Layer 7 services such as App Firewall, App QoS, IPS, and UTM. For example, social media sites like Facebook and YouTube may be blocked for most users, but access can easily be provisioned for users on a marketing team. There are two options for deploying the user firewall for flexibility and scale: Integrated User Firewall, Juniper Identity Management Service. Click each option to learn more. The diagram shows the process used for Integrated User Firewall. 1. The domain user logs in to the domain from a domain member device. 2. The user attempts to make a connection through the SRX device, which causes a new firewall session to be initiated. The normal logical packet flow is followed, and the matching security policy has an additional match criteria field called source identity. It defines the identity of a user's source IP address from a user-to-IP mapping. 3. The SRX checks local authentication tables for a matching user-to-IP mapping. If the user has already been authenticated, the SRX has the user and role information. If no local entry is found, the SRX queries the Active Directory server. 4. Traffic is evaluated against a configured security policy to allow traffic through to the web, application, and file servers. The Integrated User Firewall feature introduces the ability to authenticate users through an integration with Microsoft Active Directory. The user ID process in the routing engine implements a Windows Management Instrumentation Client, or WMIC, to communicate with the Active Directory controller and monitors the event log for changes. Using this information, it can abstract IP address to user mappings and adjust them to reflect any changes. The user ID process then uses Ldap to query the Ldap service interface of the Active Directory server to correlate users to the groups to which they belong. Having the IP address, Active Directory user, and the group information, the user ID process then generates an authentication entry. This is published to the Packet Forwarding Engine Authentication table and can be now used by the User Firewall module to enforce individual users and user groups in the security policy. The limitations for an integrated user firewall are: Active Directory domain controllers older than Windows 2003 and clients older than Windows XP are not supported. Maximum of 2 domains and up to 10 Active Directory servers are supported per domain. Tracking the status of non-Windows Active Directory users is not supported. IPv6 addresses are not supported. Logical systems are not supported. The WMIC does not support multiple users logged onto the same PC. The Active Directory configuration involves 6 steps: Active Directory communication, general information, new domains, domain settings, user group mappings, IP to user mappings. Click each step to learn more. Configuration of the access profile will enable the firewall authentication captive portal used for unknown and unauthenticated users. You must set the authentication order to check the defined Ldap server. Next, configure the Ldap server's IP address and, optionally, the port. The Ldap options include the base distinguished name, search filter, and the search administrator credentials. To create an access profile in Jweb, you must first navigate to the Configure, Users, Access Profile workspace. Then you can begin creating a profile by clicking the Add button at this workspace. To configure the Ldap server information, you must name the access profile and then specify the Ldap server IP and port information. Note that you can also specify additional parameters for the Ldap server, such as the retry, routing instance, source address, and timeout parameters if needed. You can also optionally configure the authentication order. Next, you must configure the Ldap options for the access profile. Begin by configuring the base distinguished name that defines the users within the base distinguished name field. Then, you must specify the name of the filter that is used to find the user's Ldap distinguished name within the search filter field. Then, enable the Admin Search field to perform an Ldap administrator search. If you do not select this option, the search is anonymous. Next, specify the distinguished name of an administrative user. This distinguished name is used in the bind for performing the Ldap search. Lastly, specify the password for the administrative user. The process of configuring the security policy involves 3 steps: configuring the user identity, selecting user IDs, specifying the authentication parameters. Click each step to learn more. Welcome to the Lab section of this module. In this lab, you configure and verify IPS and Integrated User Firewall. At the end of this lab, you will be able to configure IPS using Jweb, verify IPS, configure Integrated User Firewall using Jweb, verify Integrated User Firewall. Click the Start button to view a guided demonstration of the lab tasks. Part 1. Loading the baseline configuration, IPS. In this lab part, you become familiar with the access details used to access the lab equipment. Once familiar, you use Jweb of the VSRX devices to load the starting configuration for Lab 4. Click each step number to view the step.